Hello friends, welcome to the final part. In this section, we will create a new blend tree for the player that will be activated when an enemy is detected. To start, let's download a new rifle fire animation for SWAT and extract the animation by hitting Ctrl+D. Once that is done, we need to go back to the player animation controller and create a new blend tree. This blend tree will activate once an enemy is detected and change the player's behavior, making him ready to attack the enemy. The blend tree will have 5 branches, and we will set up the POSCs and POSI accordingly. Each animation clip will be run based on the least fraction of change on the joystick. We will also need to add 2 transitions between the blend trees. Finally, we will create a new parameter that is a bool type. This new parameter will be set to true by the script once an enemy is detected, and it will switch the player's behavior from idle, walk, and run to the next blend tree. The transition lines currently do not have an exit time, so you should deactivate them. Afterward, go to the conditions section and click on the plus button. From there, you should search for the fire pose parameter and set its value to true, which means active the next blend tree. The return transition line also has a condition, but it should be set to false. By doing this, once the fire pose value returns to false, another switch will occur between the blend trees. Let's make the zombie character ready. It has 2 animations, idle and walk. When the zombie detects the player, it should start walking towards them. To do this, I'll repeat the same process I did for the player's animator controller. First, I'll add a new parameter named walk, and then create a transition between each animation with a condition. This will activate the walk parameter and make the zombie move. Great! The next step is to add a Nabmesh agent to the zombie character. Also, it needs to have a collider to be detectable by the player. To enable the player to detect the enemy, I created a script that sends out a sphere ray cast around the player at a specific distance. Using tags and layers, this script gathers information. Additionally, we need to disable the fire post parameter, which shouldn't have been active in the first place. I have also developed several scripts to manage players, zombies, and bullets. I'll go over each one of them and provide you with their scripts. I want to remind you that I created a 2D circle that acts as the player detection boundary and also added a particle system for firing bullets. To start implementing this, we need to attach the player manager script to the player character. This script has a few parameters that we will explain one by one. The next script that we need to attach is the zombie manager, which is responsible for making the zombie move and chase the player. Okay, so to configure the player manager script, we need to make a few changes. Firstly, we need to determine the exchange of fire rate. Secondly, we need to set the y-axis as the height, which the bullet will start to move. Thirdly, we need to set the bullet speed, which is the speed of the bullet movement. Lastly, we need to set the target layer to determine who is an enemy and who is not. To handle this situation, I will create a new tag named enemy. This tag is important for detecting game objects. Similarly, for the target layer, which currently does not have an enemy layer, we need to follow the same process of creating a new tag. After creating the new layer, we must assign it to the zombie character. After creating a new layer, select the Player Manager Game object and choose Enemy from the target layer. Bullet Fire Pose is a transform variable type that represents the position where the bullet will be instantiated. The next step is to place the weapon in the SWAT character's hands and make sure it aligns with the character's movements. I suggest adding the weapon to the right-hand joint object for better functionality. Currently, the weapon does not have any material. To fix this, assign the new material to both weapon children and add the texture to the material. We should also adjust the size of the weapon to make sure it fits with the player's body. To simplify this process, we can play the game and observe the current position and rotation of the weapon. As we can see, its current position and rotation are not ideal, but we can manually adjust them to achieve the best possible result. During play mode, I will adjust the position and rotation of the weapon to align it with the player's hands manually. Once you're satisfied with the result, the next step is to copy the transform component properties and apply them in edit mode. To get the position and rotation data of the weapon game object, you need to follow these steps. First, select the object and click on the three-dot button. Then choose Copy from the menu. Next, select Component to copy the position and rotation data. Once you have the data, stop the game. After that, click on the three-dot button again, but this time select Paste instead of Copy. This will paste the previously copied position and rotation component values onto the weapon. Great! Everything seems to be working well. The weapon is now aligned with the player's movements in all situations. Now we need to determine the position from which the bullets will be fired. To achieve this, we can make use of a sphere and place it on the weapon silencer. Once done, we can add it to the bullet fire pose variable in the player manager script. Let's create a bullet game object using a simple sphere with a trail renderer. Adjust its size, add a trail renderer component, and set it up like me. As you may remember, I've created a script for the bullet. Let's take a closer look at it. I utilized the onEnable method, which means that the bullet is not active at first and only becomes active when its rigid body component wakes up to start affecting its velocity and force. When the bullet hits an enemy, it becomes inactive. Using the onCollisionEnter function, we can determine whether the bullet has hit a zombie or not. If it does hit a zombie, the bullet is deactivated. If there is nothing in the way of the bullet, it will become inactive after 2 seconds. Let's add a rigid body component and deactivate the game object. As you can see, the mesh renderer component will also be deactivated. We will also need to create a new folder named prefabs to store our prefabs. Next, we need to declare a desired range for detecting enemies, which will represent its name with a radius. Lastly, we need to add the bullet prefab to the player manager script. It's time to take a look at the player manager script. This script manages the player's shooting mechanics and interactions with enemies. Let me explain the variables. First, bullet direction stores the direction to fire bullets. Aim boolean indicates whether the player is aiming. Radius, detection radius for enemies. Fire rate, cooldown between shots. Bullet list, a list of bullet objects for reuse. Bullet fire pose, transform for the bullet spawning position. Target layer, layer on which to detect enemies. Firing effect, particle effect for firing. Detect area, renderer to visualize the detection area. In the start method, it creates a pool of bullet objects for efficient reuse, and in the update method, it will cast a ray to detect enemies in front of the player. If an enemy is hit and the player is aiming, sets the bullet's direction towards the enemy. Calls the fire function to shoot a bullet. The cast sphere ray function. Imagine your character has a bubble around them. This bubble acts like a special radar that can sense any bad guys who try to sneak up too close. That's what the cast sphere ray function does. It has two parameters. A vector 3 variable, the player's current position. Float distance, the radius of the detection sphere. The fire function is responsible for firing bullets in the game with a minimum time interval between consecutive shots. This function uses the time library to track in-game timing and the next fire variable to keep track of the last shot's time. If the current time is more than the fire rate plus the next fire time, it's time to fire. The function will search for available bullets by looking for an inactive one. If such a bullet is found, it will be activated and prepared for firing. The bullet's position will be set to the firing position and it will be activated in the game world by setting set active true. A force will then be applied to the bullet's rigid body component, using bullet direction and bullet speed for direction and velocity. The purpose of this function is to identify any enemies present in a specific spherical area around the player. The function uses a vector 3 type variable called player to determine the player's position. The variable distance indicates the radius of the sphere that needs to be checked. To detect any enemies present in the sphere, the function uses physics overlap sphere method. The colliders that are detected by this method are then stored in an array called colliders. Let's review the script for the zombie manager. In the start method, it receives components for navigation and animation, such as navmesh agent zombie and zombie animator. And in the update method, if the attack is true, sets the zombie's destination to the target position using navmesh agent zombie's set destination method, making it move towards the player. Also will call cast sphere ray to check for players within a 4-unit radius. What happens in the cast sphere ray function? If a collider has the player tag, sets target to the player's transform, and calculates the square distance to the player by SQR magnitude. If the player is close enough, activates attack mode by setting attack to true. Triggers the walk animation if not already playing using zombie animator, set boo walk attack. We need to add the player tag to the player. Once that's done, we can move on to adding the firing effect to the silencer on the gun. I've already created the effect, but it's not included in the downloadable project on GitHub. If you're interested in getting the full source code, I suggest checking out my Patreon account, although I haven't created it yet. Final step is to implement the detect area as a simple plane with a transparent texture. The scenario is that when the player detects the zombie, it will turn from green to red. After the player gets close enough to the zombie, it switches to shooting mode. However, currently there is an issue where bullets fire when the player is not moving. This problem will be addressed later. For now, let's go back to the Player Manager script and add a simple code to change the color of the detection area. Additionally, I need to verify if the bullets were instantiated correctly in the start method. So far, everything seems to be working well as 20 inactive bullets were created. Let's address the issue of bullets not firing properly. As I mentioned earlier, the player can only fire if the ray cast line detects the collider of the zombie. However, the zombie's collider is not large enough to obstruct the player's weapon ray cast, so we need to increase its size. To fix this, I plan to add more layers and adjust the physics matrix to make certain layers incompatible with each other. Additionally, the player will require a collider to be detectable by zombies. These changes are relatively straightforward to implement. Okay, let's start by adding a capsule collider to the player and adjusting the scale of the zombie collider. Next, we'll create a new layer for bullets and set it to not collide with the player collider. We can do this by going to the Physics tab and unchecking the appropriate layers, which will make them ignore each other. Once we've done this, the zombie will start chasing the player, and the player will be able to fire constantly without any issues. I want to change the atmosphere of the game, so I will turn off the lighting. To make the camera follow the player, we can use the Sin Machine package. Go to the package manager, download it, and set it up as I did. I hope you found this tutorial helpful. Don't hesitate to ask any questions, and please subscribe for more content. Also, don't forget to give the video a like.